Chapter number 8, sound. Let us consider the term sound. Sound is energy which transferred from one point to another point in the form of waves. साउंड ही काय एनर्जी ती एका पॉइंट पासून दुसऱ्या पॉइंट कडे वेव्हच्या स्वरूपात जात असते. लेट अस कन्सिडर ए ड्रम विच इज सोर्स ऑफ द साउंड. व्हेन साउंड इज जनरेटेड हियर we consider the position of listener. Then sound is propagated from point A to point B and it travels from A to B with the help of waves. या ठिकाणी साऊंड म्हणजे काय एनर्जी. ही एनर्जी एका पॉइंट पासून दुसऱ्या पॉइंट पर्यंत जात असते. कशाच्या सहाय्याने? वेव्हच्या स्वरूपात जात असते. आता वेव्ह म्हणजे काय हे बघूया. वेव्ह इज an oscillatory and periodic disturbance traveling through a medium without change in the form. Wave म्हणजे काय? Oscillatory periodic disturbance traveling through a medium without change in the form. यामध्ये वेव्हचा फॉर्म बदलत नाही. आता पुढचा जो मुद्दा आहे तो बघूया आपण. टाइप्स ऑफ वेव्स. टाइप्स ऑफ वेव्स. First type or type A, that is mechanical waves. Mechanical wave. A wave which requires material medium for its propagation is called mechanical wave. ज्या वेव्हला कसली गरज असते? मीडियमची गरज असते. कशासाठी? फॉर प्रपोगेशन. अशा वेव्हला आपण मेकॅनिकल वेव्ह म्हणतो. फॉर एक्झाम्पल साऊंड वेव्स. Waves on water surface, that is water waves, are mechanical waves. दूसरा जो टाइप आहे तो म्हणजे इलेक्ट्रोमॅग्नेटिक वेव्स. A wave which is oscillatory disturbance of electric and magnetic field. A wave which is oscillatory disturbance of electric and magnetic field. Such a waves are known as electromagnetic waves. For example, light waves. Now, third type, matter waves. Matter wave, a wave which is associated with any object which is in motion is known as matter waves. ही वेव्ह जी आहे ती कुणाशी संलग्न आहे? एनी ऑब्जेक्ट. कोणत्याही ऑब्जेक्टच्या संदर्भात ही त्याच्याशी संलग्न असते की जो ऑब्जेक्ट कसा असतो? इन मोशन. जो ऑब्जेक्ट मोशनमध्ये असतो त्याच्याशी संलग्न असलेली वेव्ह म्हणजे काय? मॅटर वेव्स. नाउ नेक्स्ट, that is transfer waves. A wave in which particles are vibrating perpendicular to the direction of propagation of wave is called transfer waves. ज्या वेव्ह मध्ये मीडियमचे पार्टिकल कसे व्हायब्रेट होतात? perpendicular to the direction of propagation of wave. Such a wave is called transverse waves. Next type is longitudinal waves. Next type is longitudinal waves. A wave in which particles are vibrating parallel to direction of propagation. A wave in which particles are vibrating parallel to direction of propagation of wave. यामध्ये मटेरियल पार्टिकल कसे व्हायब्रेट होत असतात पॅरलल टू डायरेक्शन ऑफ प्रोपगेशन ऑफ वेव्ह. अशा वेव्हला आपण लॉन्जिट्युडनल वेव्ह म्हणतो. नेक्स्ट वेव्ह इज प्रोग्रेसिव्ह वेव्ह. A wave which advances in one direction is known as progressive wave. कोणती वेव्ह जी वेव्ह एकाच दिशेला जात असते तिला काय म्हणायचं प्रोग्रेसिव्ह वेव्ह. ऑल टाइप्स ऑफ वेव्स आर प्रोग्रेसिव्ह वेव्स. नाउ नेक्स्ट इज वी आर गोइंग टू स्टडी equation for a wave. How wave is represented? ही वेव आपण एका इक्वेशन ने रिप्रेझेंट करतो. लेट अस कन्सिडर a wave traveling along the positive x-axis. Along y-axis displacement is represented. This is wave. At any point, at any time t, p is the position of the particle. It is at a distance x from the point O at time t. Displacement of the wave is represented by yxt. It is equal to a sine kx minus omega t plus y. Sine function is used because the motion of the particle is simple harmonic motion along the x-axis. This is waves traveling along the x-axis. Where a is amplitude. What do you mean by amplitude? Maximum displacement of the particle from the mean position. K is wave number. Omega is angular frequency. Phi is initial phase. Now, when wave is traveling along negative x-axis, then it is represented by a sine kx plus omega t plus y. When wave is traveling along the negative x-axis, then here the sign is plus sign. This is representation of wave with the help of equation. Now next is speed of transverse wave. We are going to write the formula for speed of transverse waves. Let us consider a string connected to rigid support. Wave is produced on this string, which is transverse wave. tension T is given by mg, that is weight attached to the string. L is length of the string. Capital M is total mass of string. Therefore, mass per unit length M is given by capital M upon L. Total mass of the string divided by total length is nothing but mass per unit length. Tension is equal to mg. Velocity of the transfer wave along this string is given by V is equal to under root of T upon M. Velocity of transfer wave along this string is given by under root of T upon M, where T is tension, M is mass per unit length. The proof of this equation is out of the syllabus, it is out of the book, out of the 11th standard, so directly remember this formula. Now next, speed of longitudinal wave. Speed of longitudinal waves. Now sound wave is longitudinal wave. We can consider here speed of sound wave or Newton's formula. For speed of sound in air. Let us consider the sound wave which is traveling through the air having elasticity E and density rho. This is also known as elastic constant. And this is density of air. On these two parameters, the velocity of longitudinal wave is depends. Therefore, velocity of longitudinal wave is given by E upon rho, under root of E upon rho. This is formula given by Newton. This elastic constant is also known as modulus of elasticity. According to Newton, during the propagation of sound wave, there is change in volume. Here we observe expansion of air. Here we observe compression of air. This is known as compression and this is known as rarefaction. During the compression, there is increase in temperature of air. During the rarefaction, there is decreasing temperature of the air. But compression, according to Newton, compression gives heat energy to the rarefaction. Therefore, temperature of both is same. So, according to Newton, this change in volume is an isothermal change. That is, change takes place at constant temperature. The change in volume is an isothermal change, and the elastic constant is known as isothermal bulk modulus. Isothermal bulk modulus. Isothermal bulk modulus is given by atmospheric pressure according to Newton, and atmospheric pressure is equal to H dg. H is barometric height, D is density of mercury, G is acceleration due to gravity. Therefore, speed becomes, we can write this as a P upon rho. This is equal to h dg upon rho. This is the formula. This formula is known as Newton's formula for speed of sound in air. Now we are going to calculate the speed using this formula. We are going to calculate the speed of the sound using this formula. We have V is equal to under root of h dg